So when you see a question like this, a circuit like this, you must realize that we have to use Kirchhoff's loop law in this problem. That is the first thing you should realize. Next, you try to determine, if possible, in which direction the current flows. See, in this circuit, there are two cells. This is 12 volt, this is 6 volt. Its EMF is higher, so this will control the current in the circuit. So the current will flow here in this direction, anti-clockwise direction. Now let me add here that even if you assume that the current is flowing not this direction, the current is flowing in the opposite direction, you will get the same answer, the correct answer. Okay, now let's use Kirchhoff's second law in this circuit. So I will be traversing it in the same direction as the current flow. So let me start from this point, point B. So from point B, when I come here in this cell, I am entering from the negative terminal. So the EMF of the cell, I will write plus 12. Okay, this is the convention we use. Then here I am traversing in the same direction as the current, so potential drop in this resistance, the internal resistance of the cell, potential drop will be negative. So resistance into current, this is the potential drop here. Then I reach here, so there will be potential drop here. I am moving in the direction of the current, so this will be negative. Resistance is 3.7, current is I. Okay, so we reach this point. In this cell, I am entering from the positive terminal, so its EMF will be minus 6. Remember the convention? Okay, then there will be potential drop in the internal resistance. I am still moving in the direction of the current, so minus 0.1 into I. I reach the starting point B, so that means the loop is complete, so this is equal to 0. This is Kirchhoff's loop law or voltage law, the second law. Clear? Now from here we can find the value of I. So what do we get? 0.2, 3.7, so 3.9, 0.1. So this will be 4I. I have taken it to the other side but written it here. This is 12 minus 6. So this will be 6. So that means I will be equal to 1.5 ampere. Clear? Once we have found out the current I here, I can find the potential difference between point A and B. Again, we will apply this law, Kirchhoff's voltage law, but we will apply it only for this portion of the whole circuit. So I will start from this point. So I am starting from this point, I will come and stop at this point. So this time I will write voltage at B, it is potential at point B. Entering this cell from the negative terminal, so like before, this will be plus 12 and the potential drop will be minus 0.2 I in the internal resistance. So then after this I reach this point, so that is potential of A. Okay? Now we have to find the potential difference between VA and VB. So I transfer it there. So this will become VA minus VB equal to 12 minus 0.2. So instead of I write 1.5. So this becomes 12 minus this will be 0.3. So the answer will be 11.7 volt. Clear? See, in this problem we applied Kirchhoff's second law twice. Once for the whole loop to find the current I in the circuit, and then we applied it for a portion. So we started from this point, so potential of B, then whatever was the potential drops here, Then we stopped here, so potential of that. From there we got the answer. So this is the way this type of problems can be solved.